Hello people, good morning, good afternoon, whatever time we end up doing this. I hope you had a lovely long weekend, that you actually did something productive. It was Mother's Day on Sunday, so I hope you did something nice for your mums, because they are having to put up with you, as you know, every day. So, we're coming back, we're going to continue with geometry, with interior and exterior angles, and we're going to do a little bit of an investigation. We're going to do a little bit of research and see if we can find something new, right? So we know that the angles in a triangle add up to, so all these three angles here add up to 180 degrees. We know that angles in a triangle add up to 180 degrees. We know that. And we know as well, or we should know, that angles in a quadrilateral, so any quadrilateral, doesn't have to be a square, but any quadrilateral, we know, they add up to 360 degrees. We know that. But why is that? But if we know what the angles in a triangle add up to, and we know what the angles in a quadrilateral add up to, well, what about a pentagon? Do we know what the angles in a pentagon add up to? And what about a hexagon? Do we know what the angles in a hexagon add up to? And if we know that, well, what about a heptagon? Heptagon, 7 sides. So 1, 2, 3, 4, 5, 6, 7 sides. Do we know what the angles in a septagon or a heptagon add up to? Or what about an octagon then? What about an octagon? 1, 2, 3, 4, 5, 6, 7, 8. Do we know what the angles in an octagon add up to? What about nonagon, a 9-sided polygon? Or what about a decagon? Or what about a 22-sided shape? Can we find that out? And that's what we're going to explore today. Right. We know that the angles in a quadrilateral add up to 360 degrees because I can actually split the quadrilateral into two triangles. And 180 plus 180 is 360. So there you go. That's why the angles in a quadrilateral add up to 360 degrees. Because I can split it into two triangles. Now some of you can go and say, oh, but hang on, you can split it into 4 triangles. Yes, I could, but that would be very wrong, because I would be counting that angle there, and that angle there, that angle there, and that angle there, and those are not interior angles in a polygon. I am trying to find the sum, the total, of all the interior angles in a polygon. So it doesn't make sense to cut it into 4 triangles like that, because I will be counting angles that are not part of the interior angles in the polygon. So that doesn't make sense. So in a quadrilateral, I've got 2 triangles. In one triangle, I've got 1 triangle. In a quadrilateral, I've got 2 triangles. How many triangles can I split a pentagon into? Well, if I'm careful, that'll be 1, 2, and 3. That's 3 triangles. So 180 times 3 is 540. So the sum of the interior angles in a pentagon is 540 degrees, because I can split it into 3 triangles. Well, what about a hexagon, a 6-sided shape? Into how many triangles can I split it? Let's find out. There'll be 1, 2, 3, 4 triangles. 1, 2, 3, 4 triangles, 180 each. 180 times 4 is 700 and 20 degrees. What about the septagon then? The 7-sided polygon. Into how many triangles can I split it? 1, 2, 3, 4, and 5. 5. 180 times 5 is 900 degrees. So it turns out I can find the sum of the interior angles of any polygon by splitting it into triangles. And hopefully you can see a pattern here. What about the octagon? Into how many triangles am I going to be able to split an octagon? You're right, it is 6. So that'll be 1, 2, 3, 4, 5, and 6. 180 times 6 is 180 times 6 is 600 plus 400 is 1080 degrees. Because in one triangle, I've got only one triangle, so that's 180 degrees. In a quadrilateral, I can split it into 2 triangles, so that's 360. A pentagon, I can split into 3 triangles, 540 degrees. A hexagon, 4 triangles. A heptagon, 5 triangles. An octagon, 6 triangles. So it turns out that any polygon, no matter how many sides, I can split it into how many triangles? 1, 2, 3, 4, 5, 6. What's the link? It is 2 triangles less than the number of sides. So if I have a 20-sided polygon, I have a 20-sided polygon. What do the angles in a 20-sided polygon add up to? What do the interior angles in a 20-sided polygon add up to? Well, we said that the number of triangles I can split it into is 2 less than the number of sides. So if I've got 20 sides, 2 less is 18, multiplied by 180, and that would be however many degrees that is. I haven't got a calculator here, but you can work it out. It's not difficult to do 180 times 18. So can we find a formula that is going to work for any polygon, whether it's got 40 sides, 100 sides, n sides? For an n-sided polygon, we've got that S, which is the sum of the interior angles. Let's put it like that. S, the sum of the interior angles is going to be the number of sides, take away 2, because we said that every polygon can be split into 2 triangles less than the number of sides. A pentagon was 3, 5 minus 2 is 3. An octagon was 6 triangles, 8 minus 2 is 6. So it's the number of sides take away 2 multiplied by 180. And that formula you need to learn. That formula will not be given to you in the exam. You need to memorize that. The sum of the interior angles in a polygon is the number of sides take away 2 multiplied by 180. And hopefully you're going to take notes of all of that. Sorry, I'm still here. I was going out of frame. All of that is going to make sense to you. Please let me know if it doesn't. And that's what I wanted to talk about today in less than 10 minutes. There you go. Well done. Keep working. I'll see you soon. Bye.